Hello and welcome. So today we're going to be starting our unit on systems of equations. So basically what that means is we're going to be given a set of equations with a different number of variables. And so our job is to figure out a set of numbers that works for those variables that makes all of the equations we were given true at the same time. So if I'm looking at example number one, I've got x plus 5y equals or plus 3z equals 17, 4y plus 3z equals 9, and z equals 1. So what I need to do is find one value for x, one value for y, and one value for z that will make all three equations come out true. So I've got my three equations written out. When I'm working with my system of equations, I always want to start with the simplest row first. So the one that needs the least amount of work is this guy right here, where it says just z equals 1. That's already simplified all the way down. It's already solved out for me. I don't need to do anything else with it. So from there, what I'm going to do is look for my next simplest equation to solve. And it looks like it's this guy in the middle. So what I'm going to do is take the answer from the red equation and plug it in to the purple. So since my red equation tells me that z equals 1, I'm going to take that z in the purple row, replace it with a 1, and then solve this to get my y. So first I'm going to simplify what I have. So we know that 3 times 1 is just 3. And then from there, we're going to try to get the y by itself. So I'll subtract the 3 on both sides. 9 minus 3 will give me 6. The 4y will just carry down. And then from there, I will just divide the 4. So my final answer for y will be the fraction 3/2, because I want to make sure that I reduce everything before I start plugging back in. So 6/4 reduces to 3/2, so that's my value of y. All right, so coming back to the top, we know that z equals 1. We know that y equals 3/2. So the only thing we have left to figure out is the x. Notice the only equation we haven't used yet is the first one. So we're going to do the same thing we did for the middle row, but since we have values of both z and y, we can actually plug them both in. All right, so just like with that first substitution that we did, I'm going to replace the z with a 1. And then I'm going to replace the y with my 3/2. And then from here, I'm going to simplify, and then that will let me solve for x. So 5 times 3 halves is going to give me 15 halves. 3 times 1 is just going to give me 3. I'm going to carry the rest down. Then we're going to combine our like terms. So I know that when I have a fraction, I need a common denominator. So instead of 3, I will convert that into 6 halves. So I have 15 plus 6 to give me 21. I'm going to subtract the 21 halves from both sides. And so just like before, we need a common denominator. So we will make that 34 halves. So of course, 34 minus 21 is going to give me 13. The x will carry down. And now I've solved for my answer. All right, so my final answer for the system, I have x equal to 13 halves, y equal to 3 halves, and z equal to 1. So I can either write it just like that, or I can kind of put it together with an ordered triple. If we're going to write it grouped up like that, it's just important that you make sure that you write the numbers in order. So let's look at one more example of this. We'll make it one that's slightly more complicated. So here's another system of equations. We've got negative 2x plus 3y plus 5z equal to negative 21, negative 4z equal to 20, and then 6x minus 3y equals to 0. So just like last time, we probably want to look for the simplest looking equation first. So to me, that's the one in the middle, because it just has the negative 4z and the 20. So when I isolate that, I'm going to try to solve for the z first. So I know I need to divide the negative 4, which is going to tell me that z equals to negative 5. Then, when I move back to the top, I notice the next simplest equation is probably the one on the bottom. Now, unlike last time, this one does not have a z to plug into. It's a kind of a problem. It's going to make this a little more complicated than it was last time. But what we're probably going to want to do is just decide whether we want to get the x or y by itself first. So what I'm going to do is just add 3y to both sides. So the 6x will just carry down. And then 0 plus 3y is just 3y. And so from here, I will just decide whether I want x or y alone, and it doesn't matter. So I will just put divide the 6 on both sides. And so I know 3 over 6 reduces to half. So I have x equals 1 half y, which unfortunately doesn't simplify any further, but that's not going to end up being a problem. We've got the red equation simplified down to z equals -5. We've got the purple equation simplified down to x equals 1/2 y. So the only thing we need to do now is work with this top equation. So just like before, we're going to use our substitutions. So the z will change to -5. The x will change to 1/2 y. And then we'll simplify as much as possible. So when I'm simplifying the y, -2 times 1/2 just gives me -1. So I should have a -y. And then 5 times -5 is -25. And now we'll combine our like terms. So the two y's can go together. So -1y plus 3y should give me 2y. I can add 25 to both sides to make this cancel out. So I should see a 4 over here. And then finally, we'll divide the 2 on both sides to get our answer for y. So when we go back to what we started with, we now have a solution for y. We have a solution for z. The only thing we don't have a number for is x. But since I now have a solution for y, I can substitute in and get my final answer. So I'm going to change this y into 2. And then when I simplify 1/2 times 2, it's going to tell me that x equals to 1. So now I have all 3 of my answers, so I just need to group them together just like last time. So over here, I'm going to write them in order. So x, y, z equal to 1, 2, and -5. That's all I have for this one. I'll see you guys next time.